Hello, my name is Igor, and this is the second part of my big PLA brand comparison test where I'm comparing 14 different PLA brands, plus 2 new will be included from this video. And these are all my filaments. I bought them except the AzureFilm and these 2 new filaments which are sent to me to be included in this experiment. And this was the first time where I got so many donations after part 1. So definitely there will be a PETG version of this experiment after I finish the PLA, of course. So in this part I am testing the printability, and no, sorry, it will not be a benchy. I have a problem with the benchy, that it doesn't float. So it's very hard to explain to my youngest daughter. They are so cute, small boats, but you know, they don't float. So instead of benchy, I will print another useless object, and that will be the temperature tower. Yes, I know it's also useless, but at least I can see all those properties, the overhang, bridging, stringing, like in the benchy, and here I can do that on the different temperatures. I got several comments in my previous video that it's useless because all PLA will be equal, but actually that's good results too. I wouldn't mind if they will be completely equal. In that case, we could concentrate on different properties, like, I don't know, price, color, maybe mechanical properties, what's on sale, or what can we buy in a local store. So what can you see in this video? I will start with unboxing these 2 new filaments, so I can extend the table from the previous video. Then I will explain you how I prepared this temperature tower in the slicer, and then of course the printing, but there will be short time lapses. Only the first one I will show you detailedly the printing procedure, and at the end, conclusions. Fine, let's see our new competitors. So 2 new filament brands in this test are Eryone and 3D Active from Poland. Let's start with the Eryone. It comes with a nice vacuum pack. I make a small hole so the vacuum escaped. The package is not reusable, so I cannot close it after if I want to store back the filament. Here we have 4 holes for the end of the filament we can lock, and through these holes we can see how many filaments we have on the spool. Also we have some holes on the other side, but unfortunately they are covered by the sticker. But anyway, so we can lock the end of the filament through these holes here. Rolling is quite nice. I think I should include the rolling in final score for the spool. Let's see the information on the spool. Yes, of course the brand is here and recommended printing temperature, so all main informations are here available on the spool. Oh, and I almost forgot, if you want to buy Eryone filaments, you can use MyTechFun coupon code, or there is in the description a coupon link or something like that, and you will get 14% of the discount. And I think that that coupon doesn't have a time limit. And another new brand in this comparison video is the 3D Active from Poland, and this is sent to me by Tecbears, so I can include it in this experiment. And he wrote that the price of this filament in Poland is 13 euros, and for 1.1 kilograms. I check on Amazon, it is a little bit below $20, but again for 1.1 kilograms, so the price is very good, very cheap filament. So I'm very curious how it performs in this experiment. Let's see what's in the box. Packaging is sealed but not vacuum packaging, and also the bag is not reusable. Unfortunately, we don't have any information on the spool, so I have to write it with a marker so I don't forget what is it. one small hole where we can see how many filaments we have, but only on the lower half. That's good. Actually here it's more important before it's empty. Unfortunately only one pair of holes to lock the end of the filament. Rolling is not the best, but I don't know, it shouldn't be the problem. Quite wide spool. 86 millimeters, so it cannot fit in my filament dryer, Sunlu or eSun. Let's check the Eryone. 65. And this is the Excel table from a previous video, and I added here these two lines. I'm not going into details, you can see the scoring from the previous video. Now let's see the temperature towers. I decided to use this temperature tower from gaaZolee on the Tecbears, and in this temperature tower we can see the overhang, the bridging, the stringing, and some rounded shapes. Here you can see the overhangs from 60. Well, actually the overhang is the angle between vertical line and the surface, but you can get the point. So here I can see the overhang, and this is the top view. This is the bridging from 15 to 30 millimeters. And it is good that he provided the elements separately, so I will use these elements to put together my temperature tower, which will be from 230 to 190 by 10 degrees steps. And also I checked the lid sense, so it's allowed to use the remix, so I will modify this and I will upload to my website, so you can download it from there. And this is the Prusa slicer. I'm adding a base and then I'm adding elements as a part. Only I have to move that part by the thickness of the previous element. And this is just speed up video. I can create a dedicated video about the temperature tower if there are some requests. And when I finish, then I'm changing the temperature, printing temperature to 230 degrees Celsius. This will be the start printing temperature. And I'm changing the infill to 20%. And then I had to edit the G-code a little bit. I'm searching for the first layer on second element, right click to this small plus button, custom G-code, and I'm adding M104 S and then number in degrees Celsius. With this I'm giving it command to change the temperature. And the tower is ready for printing. I will explain only detailing the first temperature tower. So I'm cleaning the printing surface, inserting the filament, waiting the color to be changed, and I'm choosing the file from the SD card, and here you can see 1.5 hours approximately is the printing time. And this is the first layer. And here you can see the stringing test on 230 degrees Celsius. And this is the bridging, but I couldn't catch it. I will do it later. And here you can see the moment when it reduced the temperature by 10 degrees Celsius, and in less than 10 seconds the temperature is changed, temperature of the nozzle. And this is the bridging moment, my favorite in this printing. And again I captured the temperature change, and this is not speed up, so you will see in less than 10 seconds the temperature of the nozzle is reduced by 10 degrees. And basically this is repeated with every element. So I will now let the time-lapse video. This will be visible with every filament. And after this I'm marking the temperature tower and analyzing it and preparing the next one. The next one is Prusa PLA, and I really like how the filament is rolled on the spool. PQ filament. Gembird. The next one is AzureFilm. Overture filament. Geeetech. eSun. PolyPlus from Polymaker. And now Tecbears, and this is the only filament which is not the base filament but the silk PLA plus, which requires higher temperature. Unfortunately this is not what I ordered, but I cannot send it back because From US, the shipping cost me same price as the spool itself. This is Sunlu, but no brand on the spool. It's really QF on cardboard spool. It's really EE. Eryone blue. It's really active. The last one. Hatchbox, Prusa BQ, Gembird, AzureFilm, Overture, Geeetech, eSun, Polymaker, Tecbears, Amazon Basics, Sunlu, 3DQF, 3DEE, Eryone, 3D Active. Hatchbox, Prusa BQ, Gembird, AzureFilm, Overture, Geeetech, eSun, Polymaker, Tecbears, Amazon Basics, Sunlu, 3DQF, 3DEE, Eryone, 3D Active. Let's try to record the bridging. This is the Hatchbox, Prusa BQ, Gembird, AzureFilm, Overture, Geeetech, eSun, Polymaker, Tecbears, Amazon Basics, Sunlu, 3DQF, 3DEE, Eryone, and 3D Active. Hatchbox, Prusa BQ, Gembird, AzureFilm, Overture, Geeetech, eSun, Polymaker, Tecbears, Amazon Basics, Sunlu, 3DQF, 3DEE, Eryone, 3D Active. And now the conclusions. I'm not sure how much was it visible on the screen, but the bridging and overhang properties were very similar for each filament in this test. I saw some difference in the stringing. Only one filament has problem on 230 and 220 degrees Celsius. Maybe 5 or 6 filaments in this test had a little bit more stringing on 230 degrees Celsius, but in every case that was over the recommended printing temperature range. So I can tell basically every filament is this test is okay, so it will do the job and you cannot go wrong with any of these. So I will be very curious how will they perform in my third part, which will be the mechanical test, probably the layer adhesion and the tensile strength. And I hope you will follow me to that video too. Until that, thank you for watching and happy printing!